बैकग्राउंड ब्लर
कैसे करना
हवाई में है यहाँ पे
एंड पर रखो
नहीं यहाँ पे ये साइड में नहीं यहाँ पे
Yes, good afternoon to all. Is it audible?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So what we have started in the last class? What we were studying? What we have studied in the last class? That is impact. Okay. What are the different types of impact? What are the different types of impact? Direct impact, oblique impact, central impact, and eccentric impact. Is it correct? Is it correct?
Sir.
Yes. And we have studied the coefficient of restitution. Yes. Can anybody tell me? Yes, please don't talk. Sit down. So, what is coefficient of restitution? CR. Define. I want definition. The coefficient of restitution of two colliding body may be defined as it is the ratio of impulse during the restitution period to the impulse during the deformation period. Is it correct? Whenever a body is undergoing a colliding, so it has to face two phases, two periods. What are those two periods? Period of deformation and period of restitution. Okay, so those are the two periods. Next, again, this coefficient of restitution is also defined as one more term. What is that one? It is the coefficient of restitution is also defined. One more definition. One definition is it is by the ratio of impulse during the restitution to the impulse during the deformation. You have defined. One more definition is there. That is, it is the ratio of relative velocity of separation to the relative velocity of the approach. Is it correct? All of you? Is it correct?
Yes, sir.
Okay. Then you have determined the how to determine the coefficient of restitution also. Problems we have done in the last class. Okay. So I had given one problem as a homework. Have you solved? Yes. Yes or no? What is the answer? What is coefficient of restitution for? 0.2. E is equal to
0.0357. 0.03571. Minus है तो
minus आ रहेगा 0.212.
Yes, sir.
No, this is wrong. This is correct. 0.212 is correct answer. See, why you are writing minus? So what was the given data? So it is homework problem. What was the given data? U1 is given. How much it is? 3 meter per second. Then V1 is given. So we have to determine V1. Then U2 is given minus 10 meter per second. Correct? Then V2 is given 4 meter per second. Is it correct? Given data? Yes. From the apply the principle of conservation of momentum. So that is W1 into U1 okay, U1 plus W2 into U2 or V2? V1. Okay, U2 is equal to W1 V1 plus W2 V2. Okay, substitute. What is W1? It is 80 into 3 plus 10 into minus 10 is equal to 80 into V1 plus 10 into 4. Okay, you solve this one, you will get the V1 is equal to, V1 is equal to 1.25 meter per second. Then what is coefficient of restitution formula? E is equal to V2 minus V1 divided by U1 plus U1 minus U2, correct? So V2 is how much? He has given 4 minus 1.25 divided by, so U1 is 3 minus of minus plus this 10. So you can get the answer E is equal to 0.212, okay, or 211. Okay, see, always I told in the last class, what is the range for the E value? 0 is less than or equal to, E is less than or equal to 1, correct? Huh? So this is the range for the, is it minus? No, so this answer is wrong. Okay. Have you got this one? Clear, okay?
Yes, sir.
Yes, okay, fine.
Minus.
Minus, कौन सा minus? U1, U2 you are taken positive ना? इसके लिए minus V1 minus आ जाते हैं क्या? Okay, so this is the procedure. Okay, you can check it. Okay, afterwards we have done one more golf ball. We have done. Okay. Yes, okay. Take down one more problem. A ball is dropped. Next question. A ball is dropped from a height of 1 meter on a smooth floor. The height of first bounce is 0.810 meter. Determine first one, coefficient of restitution. Second one, expected height of second bounce. So these are important problems for your multiple choice question. Directly hit me ask. See, what are given data first? A ball is dropped from a height. Means initial height is given, that is h. Okay, h naught. You can take h naught or you can take h1. Okay, it is 1 meter. 1 meter. The height of the first bounce is okay. Then it is first bounce. So after bouncing, after striking the floor, it has come up. Okay, so that is h1 is equal to. So that is equal to 0.81 meter. Then yes, this h1, the ball is going in the downward direction and it is coming in the upward direction. Okay, so first of all you have to find out it is a freely falling. Okay, initial velocity is 0. Then when it touches the ground, when ball is touching the ground, what is the velocity before striking? Under root of 2gh. Okay, that you have to find out. Then after striking, how much is the velocity? That you have to find out later. Okay, so first find out velocity of ball before striking the floor. What is that one? U1 is equal to under root of 2gh1, or you can take h0. Okay, initially. So what is root 2 9.81 into what is height? Initial height it is 1 meter. Okay. Yes, 4.429 meter per second. Then velocity of ball before after striking the floor. after striking the floor. Yes, now can you tell me what is velocity? V1 is equal to minus under root of 2g h1. Okay, see, after striking, it is coming back. That's why I have taken minus. Okay, so that is nothing but minus under root of 2 into 9.81. In into it is 0.81. So this is equal to minus 3.987 meter per second. So you should know why I have taken here positive answer, why I have taken here minus negative answer. Because in while the before striking, the ball is coming towards the plate, towards the ground. That's why it is positive. After striking, the ball is going away from the ground. That's why it is minus. Okay, then okay, you know that U1 and V1 of the ball. Then what is the second material? Floor. Whether the floor is moving before striking and after striking, is it moving? No, it will be zero. Correct, na? So you can write this one. So there is no movement of the floor. There is no movement. The VE. Don't take moment. Okay. There is no movement of the floor. Before and after striking the floor. After striking. That is, it means what? It means U2 is equal to V2 is equal to 0. Is it correct? Clear, hai na, Mr. Viko? Then what is the definition of the coefficient of restitution? This is before and after striking a floor. Floor is not moving. Ball is before striking U1 and V1. I have taken for the ball is the first body. Second body is floor. So floor is not moving. That's why it is 0. So definition of coefficient of restitution. What is coefficient of restitution? E into U1 minus U2 is equal to P2 minus V1. Is it correct, all of you? Yes, substitute. What is E? E is equal to V2 is how much? V2 is 0. V2 is 0. Minus what is V1? V1 is minus 3.9. Minus of minus, it is plus 3.987. Divided by what is U1? U1 is 4.429 minus what is U2? U2 is equal to 0. Is it audible, all of you? Online.
Yes, sir.
Yes, okay. Calculate the E value. All of you. Correct. How much it is? Calculate.
Zero point 0.90.
Yes, 0.90. What is unit? What is
Unitless.
it? Yes, it is unitless. Okay. Okay. What is asked in the problem? Determine the coefficient of restitution. You are determined. Then second is expected height of the second bounce. See, initially the ball is driving the floor. Okay. How much is the height? Initial height 1 meter. After driving, second it will bounce back. Okay, it bounce back. How much is the height? 0.81. Okay, now it is coming to the coming and striking to the next second one. Again, it is going back. So how much is the third? That is second height. This is initial. This is first bounce. This is second bounce. I want to find out the second bounce. He is asking expected height of second bounce. Okay, how to determine that one? So that is. Yeah? What is that assumption? No. I don't assume that one. You have a standard formula. Okay. Okay. See, you have this one. Coefficient of restitution. What is that coefficient of restitution? All of you look at this one. E is equal to, okay, this is V2 minus V1 divided by U1 minus U2. Okay, this is the coefficient of restitution is nothing but it is a ratio of relative velocity in the separation to the relative velocity in the approach. Okay, so for the first bounce, you have taken u1, u2, v1, v2. Then can you tell me of the same kind for the second bounce? For the second bounce, v2 minus v3 minus v2 divided by u2 minus u1, u2 minus u3. Is it correct?
Yes.
Okay. For the next bounce, what will be the v3 and what will be the v2? What will be the u2 and what will be the u3? That you have to find out. Yes. Yesterday I have given. That is, what is that formula? H is equal to E square into H naught. Okay. If you take first bounce, it is H naught. If you want second bounce, H2 is equal to E2 square into H1. Okay. So you know, yeah. Okay. You want H3. H3 is equal to E square into H2. So calculate how much you get. E is equal to 0.9 square into what is H2? H2 is equal to 0.81. Yes, 6 point. That is also correct answer. H3 is equal to 0.6561 meter. So this is also correct answer. But again, there is one more method. Okay, that I will also tell. So this is also correct. Okay, or okay. So I will write this or also. Or so how to determine? Okay, is it completed?
Yes.
It's complete. Okay, write down first. See, have you got this one? How you got this one? Do you remember this formula? Yesterday, I have derived this one.
Yes.
So by that formula, if you remember this one, you can determine any bound. Okay. But the condition is you should know the previous bound height. Or else ICB कर सकते. Let velocity of the ball after striking bounce b v2, velocity of strike in this case, velocity of strike in this case v1 is equal to how much it is v1? See, this 3.987, whatever it is there, this will be now it is coming towards the down, towards the next for the next bounce, it is positive condition, it is plus 3.987 meter per second. Okay, then E is equal to, so what is E? So E is equal to, okay, next is V3 minus V2. What is the V3 value? After striking this one, 0, because that will come towards the height. 0 minus V2 divided by what is the U2? U2 is equal to this one, V1. Okay, 3.987. This should be U1. It is U1. Okay, I have to determine the V2. So V1 minus what is the V2? U2 is equal to 0. Okay, so find, you know the E value also. What is the E value? 0.9. Okay, so if you calculate this one, V2 you will get 3.586 meter per second. See, once if you find out the value of V2, then you have to find out the height. Height is equal to H2 is equal to V2 square divided by 2G. So that is V is equal to under root of 2G. करते ना? So same way. So calculate just how much you will get. H2 is equal to V is equal to 3.586 square divided by 2 into 9.81. Let's calculate H2. Same again. 63.6. H2. कौन सा?
0.655.
0.65. 0 point you will get 0.655. Okay, 0.65 you are getting. Okay,
Yes,
60 or 65. Okay, see, This is a little bit lengthy. Okay, this is little bit lengthy. If you remember this formula, you can directly do. For your multiple choice question, this is the best. Okay, therefore try to remember this formula. H1 is equal to E square into H naught. Suppose if you throw a ball that is bouncing at the eighth round, see what I am telling. At the eighth bounce, height is equal to 0.5. At the eighth bounce, height is 0.8. Can you determine the ninth bounce height? Yes, can you determine if you know the E value? Okay, that is H9 is equal to what is the formula? E square into H8 square. Okay, you should remember this one. Sorry, okay, that is H8. E square into H8. Any bounce height, if you want to determine, you should know relative velocity square into previous bounce height. Okay, just remember this formula so that आपको easy हो जाएगा. Okay, so you can underline this one. Okay, this is very, very important. This is little bit lengthy. Okay, you don't worry about this one. But answer is both are same. Have you written?
Yes, sir.
Can I go for next problem? Okay, so take down. A ball of mass 2 kg moving with velocity 3 meter per second impinges directly on a ball of mass 4 kg at rest. After the impact, the 2 kg mass ball comes 2 kg mass ball comes to rest. Determine the velocity of 4 kg ball after striking and the coefficient of restitution is equal to coefficient of restitution between two balls. Okay, see what are the given data that you should know first. A ball of mass 2 kg. So M1 is given 2 kg. With a velocity U1 is given 3 meter per second. Correct? So it impinges directly on a ball of mass 4 kg. So M2 is given 4 kg, which is at rest. Means second body is at rest. It means what? U2 is equal to 0. U2 is equal to 0. Then after impact, 2 kg mass becomes to rest. What does it mean? Yes, final velocity of which body? Of the first body. It means V1 is equal to 0. Are you getting? Then 2 kg mass of the ball becomes to rest. Determine the velocity of a 4 kg ball. See how it is there. There is a m1. Okay, it is moving with the velocity u1. There is a m2. Okay, this is in the u2 is equal to 0. It is in rest condition. It goes and it strikes. After striking, the m1 becomes 0. This m1, its final velocity is equal to 0 v1. Then this m2 will move now. Okay, this m2 will move now. This is m2 with a velocity v2. So how much is the velocity he is asking? Are you getting what he is asking? Second body is at rest condition. First body will come and hit the second body. So first body will get rest. Then second body will start moving. How much is the second body's velocity he is asking? And also he is asking what is the coefficient of restitution. Okay. Okay. So what is your first method? You have to apply the principle of conservation of momentum. Okay. So from the principle of conservation of momentum or momentum conservation. Momentum conservation. What is that one? M1 U1 is plus. I have not dictated na. Is the definition. Momentum conservation. दिया क्या मैंने? नहीं दिया. Principle of mass momentum. Okay. M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. Okay. So substitute. What is M1? 2 kg. Yes. Are you getting all of you? Yes.
Yes, sir.
So M1, Q1 is how much? Q1 is equal to 3 meter per second. 3 plus M2. M2 is equal to 4. What is the U2? U2 is equal to 0. M1, 2 into V1, 0 plus M2, 4 into V2. So calculate the value of V2. Two by 3 or 3 by 2?
3 by 2.
3 by 2 is the answer. Yes, correct. It is 3 by 2. That is nothing but 1.5 meter per second. Okay, this is correct. Then how to determine the coefficient of restitution? From the definition of CR. E is equal to V2 minus V1 divided by U1 minus U2. Okay, so what is the V2 value? V2, you have determined 1.5. What is V1? 0. Then what is U1? 3 minus what is U2? So determine the value of E. 0.5. See, you have observed what is the value range for the E? E value. Always it is lies between 0 to 1. Okay, 0 to 1. You should remember this one. E value. Okay, ho gaya. So this is what he is asking. Yes, by MCQ. So these type of problems you can expect in your MCQ. 0 to 1 ऐसे भी है ना MCQ. The range for range for coefficient of restitution. It is 0. It is 1. Lies between 0 to 1. It may be minus negative value. ऐसे भी पूछ सकते हैं or less than 0 ऐसे भी पूछ सकते हैं. You should remember it is 0 to 1. And when it is 0, when it is 1. When it is 0 and when it is 1. For the perfectly elastic body, it is 0. For the non-plastic, non-elastic, it is 1. Perfect solid it is for 1 and perfect elastic it is 0. हो गया. MCQ में आ सकते. Okay. All these concepts are going to ask in your MCQ. Yes, completed. All of you.
Yes, sir.
Can I go for next concept?
Yes, sir.
Okay. So there is one point, loss of kinetic energy. Before that one, take down the definition for the mass, that is principle of conservation of momentum. Okay. So first, next line, next page. Write on this one. This is important, definition. New point. Conservation of momentum. Momentum. See, you have written the impulse momentum equation. Correct? What is that impulse momentum equation? R into dt is equal to change in momentum. Is it correct? That is net force into instant, that is time, is equal to change in momentum. Is it correct, all of you? Are you remembering? R into dt is equal to m into v2 minus m into q1. Okay, change in momentum, final momentum minus initial momentum, we have done. If at all, whenever you consider this is a body, okay, you throw one body, okay, it will come and hit this body. Entire system is not moving. Not means the R is equal to 0. Okay, you know the impulse momentum equation, that is integration of R into dt is equal to m in vt minus m into u. Okay, if at all R is equal to 0, then this is equal to mv minus mu is equal to 0. Okay, it is nothing but change in momentum, that is initial momentum is equal to final momentum. Are you getting, all of you? Initial momentum is equal to final momentum. So that is nothing but your conservation of momentum. That is nothing but your conservation of momentum. Okay, so I'll use some words, you can write this. Okay, read them. In a system, if the resultant force is 0, if the resultant force is zero, then impulse momentum equation reduces to final momentum equal to final momentum equal to initial momentum. Such a situation situations arise in many cases because the force system consists of action and reaction of elements of the system. Next line. Resultant of system is zero only when entire system is considered but not when the free body of each element of the system is considered. Of the system is considered. System is considered. When the person jumps, next line. When the person jumps off the boat, when the person jumps off the boat, the action of the person, person is equal and opposite to the reaction of the boat, so the resultant force is zero. So the resultant force is zero in the system. If W1 is the weight of person, W1 is the weight of person, and W2 is the weight of the boat, comma. V is the velocity, of the person, and boat before person jumps out of the boat, and V1 and V2 are the velocities of the person and boat after jumping.
सर बोट का मतलब
Ship, boat means ship, जहाज बोलते ना, हाँ, that is nothing but boat. See, in order to determine the conservation of momentum, see, you have learned the impulse momentum equation. What is that impulse momentum equation? That is R into dt is equal to final momentum
minus
initial momentum, correct? So this one you have learned. Okay, so don't write on this one. Okay, don't write on for your understanding purpose. Here, see, whenever a boat is moving, okay, and the person is sitting in the boat. Okay, so the person and the boat at a time they are moving with some velocities. The
Yes,
velocity
sir.
will be equal to V. Then after some point of time, the person jumps out. Okay, the person jumps out, and with a velocity V1 is the velocity of the person and V2 is the velocity of the boat. Okay, that is final velocity. See, whenever the person is sitting on the boat, what will be the net resultant force? Net resultant force is equal to zero. Okay, because on the boat is there any external forces which are acting on the boat? No.
No.
See, this R is what? This is the resultant of all the forces. So when the boat is there, the resultant force is equal to 0. That's why when this is equal to 0, your final momentum is equal to initial momentum. Then you can apply the principle of conservation of momentum. Okay. So still it is there. So for your understanding purpose, I have drawn this one. See, again, once again, I will read this statement, whatever I have written. See, the situation again inherited. In a system, if the resultant force is 0, then the impulse momentum equation reduces to final momentum is equal to initial momentum. Correct? Such a situation arises in the many cases because the force system consists of a action and reaction of the element of the system. It means whatever action is there, that is equal to reaction. So that net reaction is equal to 0. The resultant of the system is 0 only when the entire system is considered, but not when the free body of each element of the system is considered. It means when entire boat and a person is considered, the resultant force is 0. If you consider individually person and individually boat, then that is not equal to 0. Example: when a person jumps off the boat, the action of the person is equal and opposite to the reaction of the boat, so that the resultant force is equal to 0. In this system, if W1 is the weight of the person, W2 is the weight of the boat, V is the velocity of the person and boat before jumping when they are in the boat, then V1 and V2 are the velocity of the person and boat after jumping. Okay, if this is the case, then what will be the according to the principle of momentum? That will. No. R is what? That is the entire forces in that direction. Resultant total forces in that direction. That is nothing but R. F means only one force है तो F लेने का, but there is not. It is not compulsory that there is only one force. There are multiple forces. Then you have to consider a resultant. Then, according to the principle of conservation of momentum, according to principle of conservation of momentum, that is equal to what is the final momentum and what is the initial momentum. Initially, what are the bodies are there? Can you tell me? There is a boat, there is a person. Okay, there is a person का weight कितना है? W1. Weight का boat का weight कितना है? W2. And these are moving with a velocity with what? V. Then individual person का weight कितना है? W1, W2. And after jumping, what is the weight of the velocity of the person? V2. Sorry, V1. And what is the weight velocity of the boat? V2. Okay. So if you know this much, you can write it easily. So what is the mass momentum equation? Impulse, that is mass momentum equation. That is W1 plus W2 into V divided by G. That is, what is this one? M into V. Correct? Momentum means mass into velocity. This is equal to after jumping. That is W1 divided by G into V1 plus W2 divided by G into V2. Okay. So this is the principle of the momentum equation. Write this statement. Principle. It may be stated as in a system the resultant force is 0. The resultant force is 0. The resultant force is 0. Then the initial momentum remains. Then the initial momentum remains equal to final momentum. Remains remains equal to final momentum. Okay, so this is the statement you have to remember. It may be defined as, in a system, resultant force is 0, then the initial momentum remains equal to the final momentum. Have you written? Okay, we will solve one problem on this one so that it will be get clear. Yes, all of you, have you completed?
Yes, sir.
No. Okay, oh, get it done first. Okay, they are not written. Okay, complete it fast. Screenshot layer. Okay, you can do. Yes, all of you have taken.
Yes, sir.
Yes, sir.
Can I go for the problem? Okay. Take down the problem. समझ में आ गया? What is that is principle of conservation of momentum? What is that one? Conservation of momentum. In a system, if the resultant force is equal to 0, then initial momentum is equal to the final momentum. What is the momentum formula? Mass into velocity. Initial momentum is nothing but initial mass into initial velocity is equal to final mass into final velocity. Okay, here it is the problem. 800 Newton man, 800 Newton man moving horizontally with a velocity of 3 meter per second, jumps off the end of a pier, what is pier? In the bridge. Have you studied? If it is a bridge, so whatever the fire bole kya? So that is pier of fire. Okay, all these are called as pier, column. But it is not called as column. In the usual structure, we are calling it column. Okay, but in the bridge, it is called as fire or pier. Okay, pier. End of pier into a boat, a person jumps off end of pier into a boat of 3,200 Newton weight. Determine the horizontal velocity. Determine the horizontal velocity of boat with person or man. First one, if it had no initial velocity. Second one, if it was approaching the pier, with initial velocity of 0.9 meter per second. Okay. So whatever you have studied the principle of momentum equation. Okay. Only one way at best only it is there. What is there? 800 Newton man weight is what? 800 Newton. What is this one? W1 or W2? Man weight. It is W1.
M1.
Okay, M1. Okay, if it is a mass, then it is you have to take M. Now it is given weight. Weight is equal to W. Okay, so W1 is equal to 800 Newton is given. Then moving with the velocity. So what is that velocity? V1. Person weight is given. Okay, person velocity is given. How much it is? 3 meter per
3.
second. Then he jumps off the end of the pier into a boat. Okay. Then of 3,200 Newton weight. What is this one? W2 is equal to 3,200 Newton weight. Determine the horizontal velocity of the boat. Which person? Which person means what? Which one you have to determine? You have to determine V. You have to determine. See, what is that one? There is a person. Okay, he is moving. His weight is there. His velocity is there. Okay, there is a boat. Okay, the boat is also moving. With the weight is there, and he has not given veto. He jumps off into the boat. So now he will come and rest in the boat. Now the final it is the W1 plus W2. What is the velocity? V. Okay. What he is asking? Determine the horizontal velocity of the boat with person or man. Okay. So that is V is asked. Okay. How to solve this one? So first of all, see the boat is still it is in the rest condition. So V2 is equal to 0. Okay. So to find V, see he is given second first condition. It had no initial velocity. Boat has no initial velocity. Means to find the V when first case is V2 is equal to 0. Okay. Then second case V2 is equal to minus 0.9 meter per second. Because it was approaching the pier. Initially, the person is moving away from the pier. Okay, away from the pier. Now the boat is coming towards the pier. That's why he has to take minus 0.9 meter per second. Okay. So is this clear, all of you? If it is clear, then you can go ahead. So what is then? Okay, apply conservation momentum equation. Now, by law of conservation of momentum. Yes, apply this one. What is the conservation momentum? W1, yes, tell me, plus W2 divided by G, correct? Mass हो गया into V is equal to W1 divided by G into V1 plus W2 divided by G into V2. Okay, so G get cancelled everywhere. So W1 is how much? 800 plus 3,200 into what is the V? You have to determine the V first. Is equal to W1 is 800, V1 is 3 plus W2 is 3,200. Then V2 is 0 in the first case. It is 0. So for the first case. So determine the value of V. $800 into 3 divided by 4,000.
2.80.
0.6. Yes, correct. 0.6 meter per second. So this is the velocity of the boat with person. Correct? Then find out the second case. Case minus 10. For the second case, same 800 plus 3,200 into V is equal to 800 into 3 plus 3,200 into minus 0.9. Calculate the value of V. Yes, minus 40. 999. Yes, correct. How much it is? 0 minus 0.12?
minus 0.12.
0.12 meter per second. Okay. So this is the answer. So this is the first case, this is the answer. Okay. So just you should remember the what is principle of momentum equation. Okay. W1 plus W2 into V is equal to W1 into V1 plus W2 into V2. It is initial momentum is equal to final momentum. Okay, that's all. I will continue. One more lecture. One more lecture. अभी एक लेक्चर है तो कंप्लीट होगा चैप्टर और एक chapter. That is only 1 hour, 2 hours. Okay, I will continue. Okay, now only. Okay, is it completed?
Yes, sir.
सर
हाँ बोलिए.
वो फाइंड करने को कहा है वो रिपीट से बताइए वो समझ नहीं
Okay.
आया.
See, once again, look at the problem. What is given and what is you have to determine. All of you. Okay, don't write anything. Just concentrate. What is asked in the problem. Okay. See, a man's weight is given. Okay, what is this man's weight? It is W1. Correct? Then moving with a horizontally with a velocity is given. Means there is a person. He is having weight W1 and with moving with velocity V1. Then jumps off the end of the pier into the boat. Okay, he is there at the bridge. Okay, there is a pier. Pier say what he will do? He will jump off into the boat. He was there at the pier initially. He is jumping into the boat. Okay, then boat weight is given 3,200. Determine the horizontal velocity of the boat with person. Then once the person jumps into the boat is going to move. Okay, now when he is the boat is moving, at that time what is the velocity he is asking. Okay, among them there is a condition. If it had no initial velocity, it means the boat was not having initial velocity. It is in rest condition. When the person jumps into the boat, at that time the boat has started moving. Then second, if it was approaching the pier with initial velocity. Next, the pier is here. The boat is coming towards the pier, approaching towards the pier. Okay, in that condition. So initial W1, W2, V1 is given. Then V you have to determine. This V you have to determine condition 1 is V2 is equal to 0. Okay, boat velocity is equal to 0. Then second condition is this V2 is equal to minus 0.9 meter per second. Why I have taken minus? Because person is moving in this direction, boat is coming in this direction. That's why I have taken minus. Then going through the law of conservation of momentum. You know total momentum, final momentum is equal to initial individual momentum. Okay, you know all the things. Okay, substitute the case 1, V2 is equal to 0. So that you will get the V1. In this case 2, V2 is equal to minus 0.9, minus 0.9. So that you will get the value of minus 0.12. Is it clear? Yes or no?
Yes, sir.
Yes. Okay. Next point, take down. Loss of kinetic energy. Loss of kinetic energy. Loss of kinetic energy. During collision, all of you take down this one. During collision, the kinetic energy is lost due to imperfect elastic action. Imperfect elastic action. Energy is also lost. Energy is also lost due to due to A, heat generation from vibration of colliding bodies. The loss of kinetic energy can be found by finding kinetic energy before impact and after impact. Let U1, U2 be the initial velocities and V1, V2 be the final velocities of two bodies colliding in the line of impact their weights being W1 and W2, then initial kinetic energy. What is kinetic energy formula? 1 of mv square. Okay, so initial kinetic energy is equal to 1 of m1 u1 square plus half m2 u2 square. Okay, so this can also be written as half or W1 divided by 2g into u1 square plus W2 by 2g into u2 square, correct? Can you write the final velocity? Final kinetic energy is equal to, can I write W1 V1 square divided by 2g plus W2 V2 square divided by 2g. Is it correct? Correct or no? Initial and final. Okay, then loss of kinetic energy is equal to initial kinetic energy minus final kinetic energy. Initial, no, actually whenever your body is moving after impact, it loses some energy. Okay, that energy is in the form of heat generated or sound generated or vibration. Energy is lost and again it is moving, but that final velocity is lesser than that of the initial velocity. Higher is what? Initial energy is higher. So higher kinetic energy means lower effect. So this can also be written as, see, W1 is common. Okay, so I'll write this first one. Initially W1 U1 square divided by 2g plus W2 U2 square divided by 2g minus of W1 V1 square divided by 2g plus W2 V2 square divided by 2g. Is it correct? See, from this first and this one equation, what is W1? I will take common. W1 divided by 2g. So remaining is U1 square minus U1 square, V1 square minus V1 square. V1 square. So again plus W2 by 2G is equal to U2 square minus V2 square. This is the loss of kinetic energy. Loss of kinetic energy. So you may get problem on this one, or you may get this formula directly in your exam. So loss of kinetic energy is equal to initial kinetic energy minus final kinetic energy. Are you getting all of them? Yes, sir. In the exam, he may ask problem also. So we will solve one problem based on the kinetic energy. It's completed.
Yes, sir.
Are you understanding or no? Whenever a body is moving with some kinetic energy, it strikes or it hits to the another body, and again it is moving. So initially it is initial energy and final energy is not same. Some energy is lost. How much it has lost? It has lost in the form of heat, sound, or vibration. So how much that magnitude is loss of kinetic energy. Initial kinetic energy means final kinetic energy. Okay, so we will solve one problem. Third one. A sphere of weight 10 Newton, 10 Newton, moving at 3 meter per second, 3 meter per second, collides with another sphere, another sphere of weight 50 Newton, moving 50 Newton, moving in the same line, at 0.6 meter per second. Find the loss of kinetic energy during impact and show that the direction of motion of the first sphere is reversed after the impact. Assume CR is equal to 0.75. What is CR? Coefficient of restitution. Okay. Read the question carefully. What is given? A sphere of weight 10 Newton. Okay, so there is a sphere. This is one sphere. Okay, and of 10 Newton moving at a speed of 3 meter per second collides with another sphere of weight 50 Newton. So another sphere is 50 Newton. Okay, and moving in the same line at a 0.6 meter per second. Okay, find the loss of kinetic energy during the impact and show that the direction of the motion of the first sphere is reversed after the impact. Okay, see, this is moving in this direction and this body is also moving in the same direction. Okay, after the impact, how the second body is moving? This first body is moving in the opposite direction. Okay, before impact only we will write. What is the velocity? U is equal to, okay, mass. How much is the weight? W1 is equal to 10 Newton. And moving with the velocity 3 meter per second. Then second one is how much it is? 50 Newton. So this weight is equal to 50 Newton. Then its velocity is given 0.6 meter per second. This is before impact. Okay. So you know this is U1 I will take. This is U2. Okay. Initial. Let velocities after impact B. Yes, what is the after impact? V1 and V2. After impact V1 and V2 from the principle of conservation of momentum. From of momentum. Yes, what is that principle of conservation of momentum? Initial momentum is equal to final momentum. Okay, so can I write it is W1 by G into U1 plus W2 by G into U2 is equal to W1 into V1 divided by G into plus W2 into V2 divided by G. Is it correct, all of you?
Yes, sir.
Initial momentum is equal to final momentum. Okay, substitute. This G get cancelled everywhere. So what is the W1? 10 into what is the U1? 3 plus W2 50 into what is the U2? It is 0.6 is equal to W1 is 10 into V1. V1 I have to determine plus W2 is 50 into V2 I have to determine. Okay, so what I will do? I will divide 10 by all the 10. Okay, so if I divide the 10 by 10 is 1. So that is V1. 10 by 50 by 10 is plus 5. 5 V2 is equal to this 10 here 5. 5 into 6. Okay, this will get 6. 6. Okay, 60 total divided by 10. That is equal to 6. So this is equation number 1. You got from the equation the principle of conservation of momentum on first equation. Then again one more equation. What is that one? By definition of what is that one? CR. Correct? What is CR? E into, tell me.
minus
V2 is equal to V2 minus V1. Correct? So E into what is U1? 3 minus what is U2? 0.6 is equal to V2 minus V1. Okay. So bring this this side. How much you will get? V2 minus V1 is equal to, so substitute the value. E value kitna hai? He has given E is equal to 0.75. 0.75 into 3 minus 0.6, it is 2.4. So calculate this one. Kitna de dekho? 0.75 into 2.4.
1.2.
1.8. Okay. So you know V1 plus V 5 times V2 equal to 6. You know V2 minus V1. So this is equation number 2. Adding equation number 1 and 2. Add 1 and 2. Okay. So when we add these two equations, so V1 get cancelled. 5 terms of V2 plus V2. That is 6 terms of V2 is equal to 6 plus 1.8. 7.8. Okay. I want V2 1.3 meter per second. 1.3 meter per second. Okay. Then substitute in equation number 1. How much you will get? So V1 is equal to 6 minus 5 times of V2. V2 is equal to 1.3. So how much it is? Huh? Huh? Minus 0.5? Yes. What does this mean? Minus 0.5 meter per second. Why you are getting minus? Because after hitting this 10 Newton body is coming backward. That's why you are getting minus. Okay. See, he is asking that one only. Show that, find the loss of kinetic energy. Okay, that is it. Show that the direction of the motion of the first sphere is reversed after the impact. Okay, so you can write that sentence. This impact. Okay, so after this one you have to write. This shows that after impact, 10 Newton body moves backward direction. Backward direction. Okay. Then how to find out the loss in kinetic energy? So find out the loss in kinetic energy. Yes, formula apply करो. Later. So here you can write like this also. The velocity of the first ball is the current is mute yourself. Okay. The velocity of the first ball is reversed after impact. It means either minus I na answer. What I have written? This shows after impact 10 Newton body move backward. ऐसे भी लिख सकते नहीं तो the velocity of the first ball is reversed after impact. ऐसे भी लिख सकते. Next he is asking loss of kinetic energy. So that is equal to initial kinetic energy minus final kinetic energy. Let's determine. So what is the formula? W1 divided by 2g into u square minus u1 square minus v1 square. Plus W2 by 2g into v2 square minus v2 square. Okay. आपको ये याद नहीं रहे तो डायरेक्टली यू कैन डिटरमाइन इनिशियल किनेटिक एनर्जी देन माइनस फाइनल किनेटिक एनर्जी. अब ऐसे भी लिखो. Okay, substitute and tell me the answer. W1 is 10 divided by 2 times of 9.80 into U1 3 square minus V1. So you are determined V1 is equal to minus 0.5. V1 square you have to write minus of minus 6 plus 1. Okay, 0.5 square plus V2 is 50 divided by 2 times of 9.81 into U2 is 0.6 square minus V2 you have determined 1.3 square. So what is the answer? Tell me. 1.07? Yes, correct. 1.07 joules. This is the answer you have to determine. Okay, correct answer? Yes, sir. Yes. Have you completed, all of you? So this is how you have to determine. See, I have covered all the varieties of problem. Last one variety is there. So that is pile and pile hammer. That we will take. Is it completed now? Okay. Tell me the attendance first. I will take attendance. Roll number 6. Ten, 11, 13, 15, 16, 18, 19, 20, 29, 30, 34, 36, 38, 52, present. 52. रंग नाम क्या है? अमन. 53, 53, 61, 62, 63, 63, 64. Okay, option number 6, 13, 16, 18, 19, 34, 36, 53, 62, 64.
63 present.
63%. Okay.
30 present, sir.
13 present.
18 present, sir.
13, 18, where are you? Huh?
Sir.
Right, 13. Who is
Yes, sir.
13?
30,
Restitution.
sir.
Okay. Then who is 16? Karan. 61. ऐसा है क्या? हाँ, ठीक है. और कौन है? 16 रोल नंबर. Absent. 16, 18, 19, 34, 36, 53.
18 present, sir.
18 present. Okay. So we'll go for next one more last concept. Okay. Pile and its hammer. This is the last concept. Have you heard the word pile? Pile and pile hammer and
No.
in your BCME, pile foundation. Have you heard? Yes. Okay. So means whenever the soil is weak, condition. Okay. In that case, the shallow foundation is not sufficient to provide. So there is excessive settlement occurs. In order to avoid that one, we have to go for the pile foundation. Okay. What is pile? In the civil engineering terms, it is
Yes.
a long, slender material. Okay, which carries a heavy load from the superstructure to the transfer to the substructure. Okay, so this is the pile. So before erecting the soil, they have to, what they will do, they will open the ground. Okay, so there is a reinforcement cage. What is the reinforcement? Steel cage रहता है. Okay, that cage is placed here and they will hammer this one. Okay, they will hammer and they will fit into the ground. Afterwards, they will pour the concreting. So that is the problems of pile and hammer. Okay, write on first. Draw the diagram. Yes, I'll draw this one. This is last concept. Yeah, there is hammering होने के बाद this is small w, this is capital W. Pile, hammer, this is pile. Okay, stop talking first. If the safe bearing capacity of soil is less than if the safe bearing capacity of the soil is less then a set of reinforced concrete of steel holes are driven into the soil, Such holes are known as pile. over the group of files over group of files over the group of files over the group of files structure is built the files are driven by the files are driven by files are driven by a file hammer a file hammer it consists of movable weight movable weight called hammer hammer the hammer is raised to the hammer is raised to a convenient height h and freely dropped and it is guided to fall on the pile to downward together the kinetic energy of pile and pile hammer is utilized in doing the work against the resistance of group the pile get driven by distance s now the initial velocity of hammer u is equal to 0 and acceleration is equal to g. The velocity of hammer while striking the pile is given by v1 as v1 square is equal to 0 square minus plus 2gh because we know v square is equal to u square plus 2ah. So v1 is equal to under root of 2G H. See, I will explain. So consider you want to do the hammering. Okay, so this is your side. This is your side. There is a one pile cap. Okay, this is pile, and this is your hammer. Okay, you have to drive a pile into the ground. Okay, what you will do? You have to take your pile hammer. Okay, and you have to do the freely falling. Okay, so to do so initial velocity is how much when it is freely falling? 0. Okay, when it comes and strikes this pile, there is a some velocity. That velocity you have to find out. That is nothing but v1 final velocity before striking it is equal to under root of 2gh. The freely falling at this point. Okay, so what he has done when the pile is so used, if the safe bearing capacity of the soil is less, then the set of reinforced concrete of steel holes are driven into the soil. Such a holes are known as pile. Over a group of pile structure, okay, this is structure. This is structure. Okay, over a group of pile, this structure is built. The piles are driven pile hammer driven by a pile hammer. It consists of movable weight. This is what it is movable weight. It is called as hammer. The hammer is raised to a convenient edge. Okay, this will be the height edge, convenient height, and freely dropped under, and it is guided to a fall on the pile to the downward direction together. The kinetic energy of the pile and the pile hammer is utilized in doing the work against the resistance. So whenever this pile is moving against the soil, there is some resistance force in the soil. Okay, so it is moving away. The kinetic energy of the pile and pile hammer is utilized in doing the work against the resistance of the group. The pile get driven by a distance of s. Now initial height of the hammer is 0. Initial velocity is 0. Acceleration is g. So you will get velocity is equal to root 2 gh. Then after this one, after striking, what it will become? Have you written this one? So this is before striking. What is the velocity? Root 2 gh. Okay. After striking, after striking, the hammer and pile move together, hence momentum is conserved. Hence momentum is conserved. Therefore, applying the principle of conservation of momentum. So what is that of momentum? Total weight into final velocity. So what is the total weight? Weight of hammer is W plus weight of the pile is capital W divided by G. Correct? This is total weight. Into what is the final velocity? It is P2. Okay, this is equal to. So what is your initial velocity? That is the pile is W divided by G into what is the initial velocity? That is. So final momentum is equal to initial momentum. So your aim is how much is the final velocity? Pile and pile hammer is moving. Velocity you have to determine. So velocity is equal to W divided by W plus capital W into V1. So this formula you have to remember. See, this is important. Okay. What is the V1? V1 is the velocity of the pile hammer. V2 is the velocity of the pile plus hammer. What is small w? Small w is the weight of the pile hammer. Capital W is the weight of the pile. You should remember this one. If you remember this one, then you can easily solve the problem for where v2 is the velocity of hammer and pile immediately after the strike. After the strike. After the strike. Okay. To take down the problem. A pile of hammer weighing 20 kilonewton drops from a height of 750 mm on a pile of 10 kilonewton. Stop. Pile penetrates 100 mm per blow, assuming that the motion of the pile is resisted by a constant force find the resistance of penetration. What are the given data? You have to write. So given a pile hammer weighing 20 kilonewton. Hammer means capital W, small w. Hammer, yes, it is W is equal to 20 kilonewton. Then from a height of 750, what is that one? H is equal to 750 mm. A pile of 10 kilonewton, what is this one? Capital W is 10 kilonewton. Always hammer is greater than the pile. Okay. Then pile penetrates a 100 mm. What is that one? 100 mm? In the diagram, you can see here. There is a S, okay, penetration. Again, there is a resistance from the ground. That is R. He is asking R only. So that is S is given. That is 100 mm. Then per blow, एक blow को 100 mm हो रहा है. Then what is asking? Assuming that the motion of the pile is resisted by a constant force, find the resistance of the force. Okay. Yes. Now V1 is equal to velocity of pile hammer before striking. Yes, what is that one? V1 is equal to under root 2 GH. Yes, what is that one? 2 under root of 2 into 9.81 into H is equal to 0.75. Let's calculate what is the value of V1. Huh? 3.836 meter per second. Is it correct? 3.836. Okay. Then velocity after striking. So this is what is velocity velocity of hammer plus pile after striking. What is that one? V2. What is the formula for V2? V2 is equal to this one. So small w divided by small w plus capital W into V1. Okay, what is small w value? 20 divided by 20 plus 10 into what is the V1? 3.836. Calculate what is the V2? V2 is equal to 2.557 meter per second. So you got V1, you got V2. Then you have to find out the resistance. Now by impulse momentum equation, equation. What is the impulse momentum equation? Net force into time. Okay, so that is W plus capital W. These two are moving in the downward direction. The resistance is moving in the upward direction. Okay, so when you consider this is your ground. Okay, this is the ground. Your pile is, you are moving the pile inside the ground. Okay, so how will we? This is small w is there. This is capital W is there. These two are moving in the downward direction. There is a resultant the resistance from the ground. This is R. R is moving in the upward direction. So W plus W minus R. What is the distance? Distance is yes is equal to change in kinetic energy. So what is change in kinetic energy? W divided by 2G into V square minus V square. Yes. So substitute this one. What is the small w? 10. Yes, 20. Plus capital W is 10. Minus resultant I need to find out R. Into S is equal to how much? S is given 100 mm. That is 0.1 is equal to this. See, total mass which is moving in the motion, that is downward direction. This total is nothing but small w plus the capital W. Yes. Okay. This is equal to small w is how much? That is equal to 20 plus capital W is equal to 10 divided by 2 times of 9.81 into V square is known. How much is it? 2.55. No. After final striking, see, now the body W and W is moving in the downward direction. What is the final velocity of the both? 0. Okay, that is equal to 0 square. Minus what is the initial velocity when the both are moving? That is the your V2 of the first second one. 2.557. 2.557 square. Yes. Now you can calculate the value of R. Yes. This is important. How much it is? That is equal to 129.96. That is nearly equal to 139 kilometers. 139 kilometers. This much resistance is coming from the ground. Okay. So this completes entire file. So one more problem is there. I will take this problem in the next class. You are praying to complete the class. Okay. Last one problem is there. I will take that problem in the next class, and also I will take the next chapter. So tomorrow, correct. But maybe yesterday I will do the assignment. Don't worry. Is it clear, all of you? See, once again you have to go through this one. Okay, that is loss of kinetic energy, and again restitution. Again this one. What is pile and pile hammer? Okay, you have to go through and you have to come for the next lecture. Is it clear, everyone?
Yes, sir. Sir,
Okay, tell me.
sir, there is a doubt.
Which one?
सर आपने जो असाइनमेंट दिया है
हाँ
सर वो 5 ही है क्या कि और भी आप देने वाले हो अभी?
Still I will give 6th and 7th. 6th and 7th I will give. Today I will upload. Okay. 6th
ओके,
and
हाँ,
okay. Only
थैंक यू सर.
only few problems. Okay. Easy problem I will. So today only I will upload. And within 2 days you can update. Right? Solve and upload. Okay. Any other doubt? Okay. We'll stop now. We'll continue the next one. Okay. Okay. When you are going for the next exam, you have to go through all these things. Stop.